Okay, so let's talk about graphing rational functions. So this should be familiar from last year with graphing these rational functions. Has a rule given by a fraction whose numerator and denominator are polynomials and whose denominator is not 0. So the parent rational function, sometimes referred to as the reciprocal function, is y equals 1 over x. So when you look at the domain and range, I think last year in Math 2, we would write that the domain was all real numbers except x cannot equal 0, and your range was the same thing. The range is all real numbers except y cannot equal 0, and the horizontal asymptote is where the x-axis, or is the x-axis, which is where y equals 0, and the vertical asymptote is the y-axis, which is where x equals 0. So moving forward, if we take a look at this slide here, so if we talk about graphing this parent function, so let's look at getting a bunch of points that we're going to plot, and then we'll go ahead and plot them. So I'm thinking, let's look at -2, -1, -1/2, 0, 1/2, 1, 2. Okay, so picking up with graphing this, if we put in 1 divided by -2, then my y is -1/2. So we'll plot these points in a minute. Then I'd have 1 divided by -1 is -1. Then I have -1/2. All right, let's see if we can do this. Here. Okay, so picking up where we left off, now we're going to talk about the vertical shrink. So I have some points here for x, and we're going to go ahead and put in the y, or put that in for x. So if you have 1 over 6 times -1, you're going to get -1/6, and 1 over 6 times -1/2 is going to give you 6, half of 6 is 3, so you're going to get a -1/3, and then 1 over 6 times -1/3 is going to be 1 over -2, or -1/2, and 1 over 6 times -1/6 is going to be -1. So now we should be able to fill in these as a +1, a +1/2, a +1/3, and a +1/6. So, so let's see, putting in these points, at -1, you're at -1/6, so close to 0. And at -1/2, you're going to be at a -1/3, and at -1/3, you're going to be at -1/2, so somewhere about here. And then at -1/6, you're going to be at -1. So, and on the other side, then at 1/6, you're going to be at 1, and at 1/3, you're going to be at about a half. You're going to be at a half. At a half, you're going to be at 1/3, and then at 1, you're going to be at 1/6. And remember, we have to use these horizontal and vertical asymptotes, so you know that you have asymptotes here, and you have an asymptote here. And so filling in your graph, or filling in your, okay, and so, whoops, off on that one. Let's undo that one and see if I can do a better job. Okay, so what I'm really interested in is what happens to x also as it goes towards the end behavior, but we'll talk about that a little bit more tomorrow. And then, okay, next page, translation. Remember last year that when you talked about adding on the end, it was going to move your graph either up or down. So this is a vertical translation. So this, what you're going to do is take every original point. So normally you would plot 1, 1 from the parent function. It has to go down to 1, 2. And you would plot, say 1/2 would be at 2. So you're going to go down 1, 2. So it's going to be here. And then your 2, 2 would be at 1/2. So you're going to go down 1, 2 like this. And so it's also going to move your horizontal and vertical asymptotes. So your horizontal asymptote is on the y-axis. It has to get moved down 2. So it's only actually going to move that horizontal. And your vertical asymptote is still going to be x here, where your x is equal to 0. So your points on this side then would be here and here and here. So when you plot your, or draw your, connect your dots, connect your points, you're going to have your graph look like this, and it's going to come up from here and go out this way. Okay, so that's your vertical translation, and if that was a +2, it would have moved it up. So next, we're going to look at the horizontal translation. Remember, anytime that you had it with the x, it was going to move your graph left or right, and it's going to move it in the opposite direction. So because this is a -4, this is actually going to move it 4 units to the right. So we're going to, let's take your vertical and horizontal asymptotes and put those in. Those are going to be, now your horizontal asymptote is not going to move. It's still going to be where y is equal to 0, but your vertical asymptote is going to move from x equal to 0. It's going to now be x is equal to 4. So 1, 2, 3, 4, and 2, 3, like this, so, and there's the vertical asymptote. So then you're just going to plot your points, and this will be 1 away from there, and then this direction, and this direction, and 1 away here, and this way, and this way. So your graph will be, look very familiar, and you should have done a lot of this kind of work last year. So next, we need to talk about the summary of all of this. So if we take a look here, the graph, so we're going to look at sort of ahead here. When your a is between, when your a, the absolute value of a is greater than 1, the graph is a vertical stretch here. The graph is a rational function. Sorry, I missed that one. Missed the first thing. Rational function. And it's a vertical stretch when the absolute value of a is greater than 1. When the absolute value is between 0 and 1, remember, it's the vertical shrink. And when a is less than 0, which means that your a is negative, then that tells us that we have a reflection. When y is equal to k, then it is a translation, whoops, okay, I want a translation, k units. It's going to be a translation, it's going to be either up or down. based on the sign of k. And the x is equal to h is a translation left or right and it's going to be the opposite of h. Okay, so your domain is all real numbers except where x is equal to h. And so we usually say x cannot equal the h. And then your range is also going to be all real numbers except y cannot equal the k value. So I'm going to put this opposite of h here. Okay, so next, let's kind of put all this stuff together, and I am going to talk about end behavior here. So the first thing I'm noticing is this is going to be a stretch. This is going to move your graph left 3 units. And this right here is going to move it down 3 units. Or 2 units, my bad. Okay? And let's think about how that affects your asymptotes. So your vertical asymptote has to do with the x. So, and think about this, guys. I don't want my denominator to be 0. So I want my domain to be all real numbers except x cannot equal -3. So the opposite of +3. And my range is all real numbers except y cannot equal -2 because that's actually the k value. So what I'm going to do is I'm going to come in here and we're going to graph. So x cannot equal -3, so I need 1, 2, -3, and here's where I have my vertical asymptote, and the horizontal asymptote is going to be right here at -2. And I'm not necessarily looking for exact on this. I know it's a stretch, which really means that I have to be kind of further away from this. If I were to put a nice number in here, let's say that I put in -2 for x. If I put in -2, -2 would give me a +1, right? 5 divided by -2 plus 3 would be 1. So that would be 5/1, which is 5, minus 2 would be 3. So if my x is -2, just gonna kind of pick some of these. We're going to do 5/x plus 3 minus 2, and we're going to get a y value. So 5/-2 plus 3 minus 2 means I have 5/1, which is 5, minus 2 is 3. So we're going to plot that point at -2 and a +3. -2, +3 right here. And then if I were to put in, let's say we put in, a +2, let's see what happens here. Put in a +2, and you're going to have 5/2 plus 3, which is going to be 5/5, which is 1, minus 2 is going to be -1. So we're going to have a point at 2, -1. So those are kind of far apart, but I know the idea is that this is going to, from here, it's going to, whoops, wrong thing. Okay, from that point there, my graph is going to go towards the horizontal asymptote, and it's up in here. It's going to be coming down from here, and I don't know if we put in, let's see, so if we were put in a 0, that would be 5/3 minus 2, which is 6/3, would be negative 1/3. So something, so I don't know exactly how this is going to behave right here in the middle. And I could work it out, but it just kind of gets ugly right now. I don't want to get that particular, doing this by hand. I just want to get an idea of what's happening. So now on the other side here, what if we put in a -5? So if we put in -5, you're going to have, or not -5, no, -5, well, that would work. We could do -5 plus 3 minus 2. So that would be -5 over, or 5 over -2, which would be -2.5, would be -4.5. So at -5, 4, 5, I would be at -4.5, something like this. So, so going, based on what we know, we're going to have something along the lines of the same sort of picture, and that would be good enough for me. Okay, now notice that the end behavior here, as your x's are getting bigger and bigger, where's your function going? Well, your function is actually approaching this horizontal asymptote where you have y is equal to -2. So it's approaching -2. In this side, as x is going towards -infinity, so in this going out towards the left here, your function is also approaching -2. Okay, so let's take a look at the next one. So the very last one, again, we're going to take a look and see what's going on. This is going to move your graph up 1 unit. This is going to move your graph to the left. We're moving it left again, left 2 units. And we're going to, this is going to be, this negative tells us it's going to be a reflection. So I already know it's going to change the quadrants. So it's going to be in quadrant 2 and 4. And the 2 is going to give us a stretch. Okay, so, okay, the other thing we have to think about is this is going to affect your horizontal asymptote. So your horizontal asymptote is going to move up 1 from 0, and your vertical asymptote is going to move left 2 as well. So when we were graphing these before, your horizontal asymptote is going to go here where y is equal to 1. And your vertical asymptote is going to be left at -2. And so, and we're going to be in the second quadrant and in the fourth quadrant. And let's see, so we know that we want to plot some of these points. What do we have? We have, let's see, what numbers would be nice numbers to use here. So we can actually use a 0. I don't know if that's going to help us a lot, but we'll try it. Let's see, if we use, if we use -1, you're going to have -2 over -1 plus 2, so that's going to give you a positive 1 in the denominator, so -2 plus 1 is going to be -1. If we use 0, then -2 over 0 plus 2 is going to equal, oh wait, did I divide right on that one up above? I don't think I did. I think this is supposed to be, so that would be -2, oh, I forgot the plus 1 on the end over here. So plus 1 plus 1, let me make sure I have that right. So that would be -2 over 1, so that's -2 plus 1 is going to be -1. This is going to be -1 plus 1, which will be 0. And then let's see, if we do a positive 2, then I'll have -2 over 2 plus 2. So that'd be negative 2 over 4, which is negative 1/2, plus 1 is going to give us a positive 1/2. And let's see, if we go to the other side of that and we use a negative, let's see, if we use, okay, I'm back. So let's see, we have negative 1, 0, 2. So let's see, maybe just plot these points and then go back. I have negative 1 and negative 1, so here, and 0, 0 is here, and 2 and 1/2 would be about here. And so I'm assuming that my shape then, if it goes like all the others do, is going to look like this. And if I put in some, let's see, if I put in some other points here, let's see, what can we put in? Oh, I think I was looking for the other side. Let's see, if I put in a negative 4, if you have negative 2 over negative 4 plus 2, so that would be a negative 2 over negative 2, which would be a positive 1, plus 1 is going to be 2. And then maybe putting in negative 6. Put in a negative 6, you'll have negative 2 over negative 6 plus 2 plus 1. So that would be a negative 4. Negative 2 over negative 4 would be a positive 1/2. So you would have a positive 3/2 or positive 1.5, depending on which way you want to think about it. So let's plot some of these and see if this helps. So I have negative 4 and 2, so that would be here. And I have negative 6, and I have 1 and 1.5. So something's not quite, oh wait, Miss Crooks, that's not right. Didn't plot that in the right spot. So let's see, negative 6 would be 3/2. So negative 6, 4, 5, 6 would be here because there's 1. All right, so this is going to look something, whoops. Forget I can't use that little tool. So here is, this is going to be the shape of the graph, something like this. And really what I'm interested in what's happening here. So as x goes towards negative infinity, so we're looking at the graph going to the left here, then I notice that my function is approaching 1. Well, notice the horizontal asymptote, 1. And as x is approaching positive infinity, so my graph is going in this direction, I notice that the function is also approaching 1. So there's our end behaviors. Okay, and I think that's it for today. See you tomorrow in class.